Good evening, everyone. A very warm welcome to all our participants joining us from India and abroad. It's my pleasure to host another exciting session for the Curious Mind series brought to you by the Propagation Institute for Advanced Studies. The Curious Mind series is our weekend initiative, a collective of interactive and thought-provoking sessions held every Sunday. Through these series, we connect inquisitive learners with leading scientists, researchers, and science communicators who inspire us to explore the wonders of the universe and the frontiers of technology. Each session aims to spark curiosity, deepen understanding, and remind us that every great discovery begins with a curious question. The Propagation Institute for Advanced Studies is a growing scientific platform dedicated to building one of the largest learning communities in science and research. We bring together students, educators, and scientists from diverse backgrounds to engage through talks, workshops, and citizen science programs, promoting open access to knowledge and collaboration across disciplines. Our vision is simple yet profound: to connect curious minds and empower them to explore the unknown. It's really my honor to introduce our distinguished speaker for the day, Dr. Shirsh Lata Soni, an early career researcher dedicated to the field of solar physics and space weather. Dr. Soni is currently a postdoctoral research fellow at the Department of Physics and Astronomy, University of Iowa, USA. She has also led postdoctoral positions at the University of Michigan and the Indian Space Research Organization, VSSC, Kerala. Her research focuses on the generation and evolution of magnetic switchbacks in the inner heliosphere using observations from Parker Solar Probe and the Solar Orbiter. Contributions to NASA's SWIFT mission, investigating small to mesoscale solar wind structures. Collaboration with NASA's Sunrise mission, including co-leading the Sunrise Ground Radio Lab outreach project, designing antennas and analyzing solar radio burst. Study of complex CMEs and their geo-effectiveness using in situ and remote observations. Dr. Soni has also guided numerous high school and undergraduate students through NASA-sponsored space programs and is passionate about mentorship and outreach. Today, Dr. Soni will be speaking on the need for the space science. In this session, we'll explore why space science is crucial, not only for understanding our universe, but also for shaping the future innovations and impact technology, communications, and life on Earth. Ma'am, it would be an honor for us to listen to you, and I hand over the podium to you. Thank you.
Thank you so much, ma'am. Thank you so much for this kind introduction. So let me just share my screen and then it'd be better to just start there. I guess everything is perfect. My voice.
Yes, absolutely. Absolutely.
Thank you so much. Hello, everyone. My name is Shirsh, and I'm a heliophysics researcher at the Department of Physics and Astronomy at University of Iowa. And I guess everybody is from the same time zone. If not, then good evening and good afternoon, good morning. Next 30 to 40 minutes, we are going to discuss or talk about the need for space science. And just prerequisites that there would be many terminology and some words that would be beyond your reach. So just be with me for next couple of minutes, and then if you have any question or any sort of doubt, I would be happy to answer and clarify it. So,
Ma'am, just a second.
Yeah, please.
Ma'am, just a second. Yeah. Sorry for the interruption, ma'am. I would request all the participants to kindly unmute your mic while asking the question after the session is over. Right? Thank you.
Okay. So let's start with the definition of a space weather. And before going to discuss about the space weather, I just have a little concern about this. So there are two words, climate and weather, which is very similar. They sound very similar, but there is a huge difference or distinct definition for these two. So if anybody can chat answer in chat box would be better. I would be happy to listen or hear that what you think. So the climate and space weather. There are two pictures, A and B. Just type in chat box whether A is, so let's say, what is climate, A or B? Just put in your chat box or um, or unmute yourself, whatever, if you can. Otherwise, we can go ahead. I'm asking about what is climate, A or B? Mhm. Okay, perfect. So what I can see here from the chat box, thank you. Okay, lots of comments. A, B, A, B. It's a mixed reaction, but again, what I can see is like the answer are mostly A, but there are lots of answer like A and B both. So the basic difference, and I saw somewhere someone texted that the climate is weather is more frequent, of course. So climate and weather, the basic difference is the weather is more frequent and it's change in very short time of temporal variation. But the climate is a long time variation. It's like if something changed in the climate, it will impact for decades or years or centuries. But climate is like it could be a daily weather change, or it would be a monthly weather change or yearly wise. Right? So when we are talking about space weather, it means that we are talking about the frequent changes. Okay, yeah, we are going to talk about the frequent changes in this space. And when we are talking about the space science or space weather, everything is because of the sun impact on our Earth system. It completely connects every point and they will link between these two astronomical objects. We call it space science or space weather. So the basic word-to-word definition would be the space weather refers to variable condition in the space driven by the solar activity that influences the performance and reliability of a spaceborne and ground-based technology system. Again, the main drivers would be for this space weather change could be solar flare, coronal mass ejections, high-speed solar wind, solar energy particle, etc. Again, as I said, like there would be these words are not so into your uh, directory, but again, we'll discuss this later. At the background, what we're seeing is this is sun. This is a small ball here is Earth. This blue lines are magnetic field lines. This shaded part where you can see some particles are going at these, that is a magnetosphere or plasma sphere, we call say it. And this dotted points that you are seeing, which is moving towards Earth side, these are particles, uh, or we call combination of magnetic field and plasma, which is called solar wind, which is continuous eruption from the sun. And if you just notice, there is a huge bulb, this eruption, huge bulb kind of eruption, that is called CME, coronal mass ejections. As name said, there is a mass, it means plasma. Coronal means it is ejected from the solar surface and solar atmosphere, which is photosphere, chromosphere, and corona. The majority of plasma within the ejection is from corona, the outer layer of sun. So that's why we call it coronal mass ejection. And if this ejection is earthward, it can impact Earth a lot. So in the later slides, we will discuss more about those ejections and drivers. So there are many other transient eruptions that I mentioned. So let's start with the sun and we come towards the earth side and understand like what are those small little terms or behavior what we are seeing. So let's start with the sunspot, which is over the solar surface, the surface what we are seeing with our naked eyes called photosphere. And so sun is just, sun is uh, not solid as Earth or other inner planets. It's a gaseous body, and there are magnetic fields. And when the magnetic fields trapped or twisted to each other, they just break down. And because of that, there is a difference between the main surface and the ejected surface. And because of that, there is a difference in terms of temperature, in terms of magnetic field, in terms of plasma. So that particular section known as spot, and we call it sunspot. And because of this sunspot, there are many magnetic differences. And because of those differences, there are the situation made for the eruptions. So what kind of eruption these sunspot can do is very first is solar flares. Flares is just a blast. Just imagine there is a stored magnetic energy in some of those active region, over the active region, and the stored energy is too large, too huge, that it just erupt in a second. And that eruption called solar flares. Again, if this solar flare is earthward, it can generate a lot of radiation, and that radiation come to or impact Earth in very quick way. It's just in a real time. Other major huge ejection or is coronal mass ejection, as we already discussed in the previous slide, that if there is, other than this sudden eruption, if there is a more energy, then it can convert into the solar coronal mass ejections, and then it erupt like huge magnetic field and plasma in the interplanetary system. If you can see this huge reddish shaded part, it is CME's real image. Next is solar wind. Solar wind is continuous eruption from the sun. Because of that, our magnetosphere shaped like a crab, and because of that, we have plasmasphere. I mean ionosphere. We have sustainable atmosphere and the sustainable atmosphere over Earth. So solar wind is very important for us. Um, there is Earth magnetic field next. So Earth magnetic field is a very simple dipole magnetic kind of structure, and where we have both the sides we have magnetic field north to south, but because of the solar wind, they pushed the day side of magnetic field lines, and they pushed it back to the night side, and that's why we have this crab structure of Earth magnetic field. Um, okay, so if those two magnetic field lines interacted, there could be a many kind of structures or behavioral change we can observe. So the basic thing that we see here over the Earth because of these eruptions would be a geomagnetic storm. Geomagnetic storm is just that when this solar magnetic field interacted with Earth magnetic field, they disturb the ground-based Earth magnetic uh, field, and because of that, we have sudden changes in many. We'll discuss in the later slides. So as we discuss about the many other kind of solar transients, there is a paper published recently, and I don't want you to focus for the entire picture. I just want to tell you about this observational tool here, the third panel, this one, and just focus on the size of those eruptions. So there are multiple sizes. So large scale, which is huge, bigger than Earth. Meso scale, which size is equal to Earth or less than Earth size, and kinetic scale structure, which is, of course, kinetic scale structures, seconds to minutes structures. Why I put this image to you? Because I just want to show you that where we are right now. So in situ observation is that we can observe them from there itself, where they erupted or where they are. And the remote observation is like we are observing from far to them. Like if we are imaging sun, it means we are doing remote observation. So I just want to tell you that where we are. So there are many structures or many solar eruptions that can be observed where they erupted or where they are in situ. But there are few where we just can observe them from remote, from far. And there are also a lot of gap where we can't observe them frequently, or we can't even observe them, right? So even though we are working on space weather from last 2 3 decades, still we are very far from the better prediction. So, as I said, that coronal mass ejection is huge and they can impact a lot. And they are also associated with the solar flares, which are two major solar eruptions, solar flare and coronal mass ejection. So, let's start with CME, or coronal mass ejections. So, there was a mission called Parker Solar Probe. It is the very first man-made mission which almost touched the sun. It was almost enter the solar atmosphere. So this particular images are from the Solar Parker probe, a Parker mission. Let it load. And with this, you can just see the eruption. This blast that you've seen, the blast that you've seen is the coronal mass ejection. Again, let's go back a little. This that you can see here is the Milky Way, Milky Way's center that we are seeing here. And these are two cameras from PSP, Parker Solar Probe, and we are seeing like how huge a CME could be. See the size of CME. This is sun, and this huge eruption is from there. Okay, this is one of the best observation from Parker Solar Probe. So now you see like how huge it could be. So let's see the structure of CME. So this is sun again at the right side, if you can see this. So sun is here, earth is here. If CME is erupted towards earth, what we are seeing. So we are seeing as it is blast of plasma. So what we are seeing is there's a shock in just in front of CME. This shock can disturb a lot of magnetic field in on over Earth. Just after the shock, there is a turbulent of mixed plasma, mixed magnetic field lines, etc. And then there is a cloud. Cloud is basically a very structured magnetic field loop, or yeah, okay, loop would be a better word for this, and trapped plasma within this magnetic field loop. And after that, there is a cavity. If something is pushed away, some plasma or something is pushed away, there would be a cavity behind it. We call it coronal mass ejection's core. So this structure we will see if the CME hits the Earth. Um, and so researchers are doing or trying to understand these CMEs from, I guess, from 5 or 6 decades. But still, we are very far because each CME has their own behavior, and it's very hard to define or compare to one to other CME. Again, there is one more complex things that if the CMEs are very frequent, erupting very frequent from the same direction or same orientation, they can interact. So you can understand if the one single CME is difficult to understand, how difficult would be if there were two or more CMEs interacted each other and they just impact Earth or they affect Earth. So my core research problem is to understand like how those CME interaction behaves and how they would impact Earth system. And why this is important? Because nearly 1/3 of CMEs are complex CMEs, and most major events or geomagnetic storm we observed so far in the history, they are because of the CME interaction. So okay, this is very scientific. I'm going to skip this. So when I said like CME interaction, there could be multiple kind of CME interaction. It could be homogeneous when very similar. It's like twin CME erupted from the same active region and they interact. they are easy to understand because they have very similar behavior, uh, but still they can impact a lot. They are sympathetic, where they erupted from very close. I mean, if you see sun, if they are very close active region here and there, they can simply one will one will erupt, and they can trigger the other one, and because of these trigger, they erupt simultaneously and they can interact. And analogous would be if there were two CME erupted from the two different location, longitudinally or latitudinally, they can, when they propagate into the Sun Earth line, they can interact in between the propagation. So there are many other kind of behavior of same interaction that's not needed to discuss for, at least for now. Anyways, this is just a slide deck from my last study where we were looking at three CME interactions together, and these are the different kind of observation what we could do from the space-based and ground-based observation. Um, I was just showing that how the observation works. These are observation, all images are from the space-based instruments. And we can also use model, and these are the model output. And just after this all analysis, what we found with that particular study is, because if there was only one CME, the geo impact that we got is half of the impact that we got, what we observed because of the complex CMEs. Again, I don't want you to jump into this well. So let's go back to the reality and the current situation where we are in the space weather or space science. So why this is important, because there are lots of historical events which impacted humanity or our generation a lot. So there was a big event in 1859. It was called Carrington event, and because of that, at that time there was a blackout. There was a huge geometric storm. Auroras were seen from the equator, uh, from the India itself. And I guess everybody is very well known with the auroras. These are the northern lights. If there is a solar wind impacted Earth, they and the energetic particles come to the ionosphere, they can energize the gases in the atmosphere, and because of those gases, they can just emit different colors, and we can see the auroras. Mostly these are the northern side, northern pole and south pole. But if the eruption is too huge from the sun, they can also observe from the lower latitude. Yeah, there were other listed few events. The the recent event I didn't list it here, but the recent event was 2 days back. I don't know whether it was in the news in India, but we could see the auroras from Iowa itself. Iowa means not in very low latitude, but it is in mid latitude, and it is a rare event. We could see auroras from here itself. The sky was literally colorful, very similar to the back image that you can see. And just for the information, the back image is taken by me only. Last year, 2024 May event, there was another huge event. Yeah, so it is important to study. What space weather can impact in our day-to-day daily life? So they can, of course, because of that, there would be a magnetic disturbances, geomagnetic storm, etc. But how that changes in weather can impact our daily life. So they can impact our technological system, like satellites and communication. And they can, when I said satellites, so they can interact with the satellites and they can energize them. Their electric system can fail. The other one is GPS, Global Navigation System. In this era where we are uh, totally dependent on those GPS system to go anywhere, I can't I can't go anywhere without GPS or without maps. So I'm totally dependent, and I'm sure that there are many other people like me. So it is important, and these eruption can disturb those GPS system in a second. So it's very important for nowadays. Power grids, power they can the enriched particle or radiation can also impact the power grids in over the uh, entire Earth. It doesn't matter low latitude or high latitude. Aviation system, if the GPS system can fail, will fail, aviation can also fail the communication. So that's also important. And of course, human space flights, as we are very frequent to this in International Space Center nowadays. Um, and the astronauts are outside, they're working. So it's very important to look at the radiation it can impact on astronauts or so yeah, so overall, it's very important for this present era where we are living right now. And why there's urgency, why everybody's talking, each country right now. You just name the country, I'm definitely sure that they are directly or indirectly working or concerned about the space weather, space science. And why? Because that at this time we are so much dependent on Earth, dependent on the space-based infrastructure from the morning. I mean, I don't believe that anybody is can live without phone for a week, right? So an entire phone, it's based on the technology that we have on the space, the communication. Um, yeah, communication is the best word to just describe that. So we are increasing with the space dependencies. There are more than 8,000 active satellites orbit on Earth. Um, we are working on lots of CubeSats, not only just lower latitude or not lower orbits, uh, from Sun to Earth and the beyond Earth or beyond Earth, of course. So we are working on many space-based satellites or missions that can impact with this space weather changes. And we are also now in the preparation of human exploration in different planets. So we are trying to go for Mars, Moon, etc. So we need that weather prediction very well. Um, okay, so there are three things that we need to focus on. First is what is sun-earth connection? So if there is any eruption from the sun, how how Earth directly impact for this. So this is one major focus area that one should look for. The other one is magnetosphere and ionosphere coupling. So once the eruption interacted with the Earth magnetic field, this part, the center part, what happened with the magnetosphere and ionosphere of Earth? So this is another part of research area that people are working. And again, the modeling complexity. So we have observation, of course, but it would be always good to just verify the observation with the existing science or theory we have. So the models are basically the output of theory, what we already have, and we can compare all these observations with the modeling stuff. Um, and where we are right now. So, and what are the challenges for now? So very first is, as I mentioned, that eruptions are very uncertain, and the behavior of each eruption is completely different to each other. So there is a non-linear solar dynamics, which is very hard to understand. And that's why we are limited with our forecasting. Second is, for now, at this time, with the existing missions and theories, we are still little far. We have just 1 to 2 days of forecasting. So if there is an eruption going to happen next to next day, we can predict it now, but can't predict it well before. And 2 days of prediction is not enough to save everything what I just mentioned that they are impactful. Other one is uncertainty in CME trajectories and magnetic field. I already mentioned that CMEs are um, very different from each other. So it's very hard to make a statistical study and use that study for a forecasting. We are limited with the observation. L1 is the point between Sun and Earth, where we can put our spacecrafts and they can observe Sun 24 hours, 24/7. We are limited right now. We have missions, but we are limited with the observations. I mean, not all kind of observation we have. And even though we have a very good physics, still we are limited or we are developing those interaction, how the uh, solar fields, magnetic fields, or Earth ionosphere, they all behave together. So there are a lot of underdeveloped studies we need to focus on to just get a better forecasting. Again, as where we are right now, so these are all the space missions for dedicated to study the space weather. Solar Tracker probe, which is observing sun. Solar orbiter is also dedicated to sun and very close to sun. There are other missions at Elvin Point. Which is just observing sun from remote. Wind is. Um, And these are other space mission which is in low orbit, and they are observing Earth magnetic field. There are many others, but yeah, these are the web with we are trying to resolve the solar space weather uh, connection. What we are doing right now to fill this gap. So we mean when I said like we myself, my team, and most of the other space researchers, what we are doing right now is very next mission is tracers. Right now I'm working on it, and it just launched 2 months back, and we are getting very good data for that. With that, what we are doing is we are observing cusp. Cusp is basically the magnetosphere and ionosphere coupling. We are trying to understand like what's happening. There is Sunrise mission, there is a Skip It mission, Wiggle, many others. We are also trying to use artificial intelligence and machine learning for this, and I'm very sure with that we can, what we have done in last 3 decades, now we could do the same stuff, I mean, same uh, efforts in just next 3 years, or maybe if we are very good or fortunate, maybe next 3 months. So like I'm hopeful for that. We are also working on the advanced modeling techniques. um, so hopeful they will also help us to have a better forecasting. And in this era now, we are each country is each or most of the countries are jumped into this um, field. So we have now international collaboration, and we have like global team now to fight with against it. That's all about the science. Right now, as we are going to the end of this talk, I just pull up like what I'm working right now. And if you have any question related to that, I will be happy to answer. So right now I'm working on solar physics. Solar physics, I covers switchbacks, which is kinetic scale structures, solar wind generation, heating, and the solar eruptions. I'm also working on space weather, where I'm working on how the solar eruptions impact Earth and uh, other inner solar planets. I'm also involved in some educational outreach, where my core field is solar. So I'm designing solar radio telescopes, and most of students from the PhD to schools, we have more than 2,000 worldwide students who are involved in our science sunrise ground radio lab, and they learn how to build radio telescopes, and they observe sun by themselves. So far, I involved in few missions. When I was in India, I was worked for Aditya L1 mission from ISRO. Um, Right now, I'm working for Parker Solar Probe, Solar Orbiter mission from European Space Agency, tracers from NASA again, and Sunrise going to be launched next year. But yeah, so these are all mission I'm working right now. There's another mission called Swift, which is not in line for the launch, so I haven't mentioned here. But if you have any question regarding all those missions, um, I will be happy to answer. This QR code will direct you to my LinkedIn profile. So you can just simply go there and connect with me. I'll be happy to connect you there as well. And this is for the audience who are with us right now. And if you want to be a part of this journey, what are the possibilities and opportunities? So if you're in India, there are ISRO's summer schools, and not just ISRO, there are other space-based or a space-related research institution called Physical Research Laboratory, Indian Institute of Astronomy, sorry, Astrophysics in Bangalore. There's one Ayuka in Pune, Aries in Nainital, IIG in Mumbai. So there are many other institutions, and along with ISRO, they have a summer internship program. If you are in your master's, in your bachelor's, you can simply apply for those summer schools and workshops, and you'll get fellowship for that. Yeah, it's a 2 or 3 months of schools, and best to just initiate your research career. I personally, I did my summer school in Physical Research Laboratory in Ahmedabad. So, and that's how I started my journey. Um, if you want to be in a part of, if you want to be a part of a global team, then there are lots of NASA Citizen Science Program. Just type in Google NASA Citizen Science Program. It will direct you to the website, and there are lots of program where you can just simply sitting in your home and contribute your research there. They direct you for each and single steps, and how this is important. Last year, there was a citizen scientist. It's a layman, no scientist, no science background, but he just participated in the program, and he observed two comets by himself. And there was one lady. She found a exoplanet, and the exoplanet named after her. So citizen science programs are extremely good. I strongly recommend you to go for that. And it won't ask you multiple hours of yours. Um, okay, so as I already mentioned, there are other summer programs from different other research centers in India. Short-term course and certificates, COSPER, these are all international or national organization, COSPER, CSST, and SERBS. They they give you opportunity to work with international people for 3 to 6 months or 1 month, I guess. With that certificate courses, you can interact with the leading scientists in that field. Not in space science only. You can also be part of stellar astronomy, observation, etc. But they all are basically dedicated to space science and space physics or astrophysics. Yeah, so these are all other opportunities. If you have any question regarding this, I'll be happy to answer and connect further. The one thing that I strongly recommend everybody that please make your LinkedIn profile and connect with your um, leaders in your field. So would be better always. That's all from my end. If you have any question, I would be happy to answer.
Thank you so much, ma'am. We'll start with the questions. If you have any questions, please do raise your hands. We'll pick you out, and you can ask questions to ma'am directly. Right. We'll start. We'll start immediately. Let's do Robera. You can open your mic and start the question. Robera, are you there? Are you not able to open your mic or something? Okay. Maybe there's some problem. Nicholas, we can start with you then.
Hello, Miss. Can hear my voice, right?
Yes, go
Uh,
ahead.
so, a very interesting talk. Very thank you for the talk. The question that I want to ask is because I'm currently in my final year for bachelor's, and I'm actually
Okay.
curious, like, since you're talking about it, I'm actually curious, like, is there any good groups, like astrophysics group that I could join so for my master's or PhD in the future? Like, could you recommend some?
Okay, so astrophysics is like huge. Are you interested in some particular, like, are you interested in exoplanets, or are you interested in black hole, or
Uh,
what your
for
interest?
For now, my research project is currently doing on mostly cosmology.
Okay. So you're mostly on the theory.
Uh, n- no, actually, is I study the theory part, but I try to use observations to prove the cosmological parameters.
Okay, so as I'm not from the state astronomy, but I know, and which country you are in, or you are open to anywhere.
I'm in Malaysia, but I'm open to anywhere. Yeah.
Um, Astrophysics. I know few of institution in India, but India won't entertain the international people for now, at least. Um, just thinking like which is best group. There is a okay. There is one group in Germany, Max Planck Institution. They are doing so well in astrophysics and the cosmology itself. So I would recommend you to look for that opportunity. And for masters, they covers entire your student fee. So I would recommend you to go for this Max Planck Institution.
Okay. Okay. Thanks for your recommendation.
Thanks.
Thanks, Nicholas. We'll move on to the next contestant. Ayush, you can go ahead and ask your questions. You can open your
Uh,
camera as well if you're comfortable, so that you can also take a look at it.
Thank you so much, ma'am, for this session. So my question is, why L1 point is suitable for CME detection, and what is importance for space weather forecasting?
Okay, so if you say this, Alpha point is somewhere here, right? And it has very similar orbit as we have on Earth. So it's a geosynchronous orbit where we can, as we move in our orbit, the L1 point is also moving stable. So if we launch or if we make any satellite at L1 point, it will always be there. It orbit there, but it will always towards the sun faces. So if we move around, if we orbit towards the sun, um, it will observe 24/7. So we will have continuous observation from for sun. And what was the follow-up question? Why CME can observe from this? You asked, right? So
Uh,
CME can erupt from in any direction, right? If it is from somewhere in the limb of sun, they can erupt from different direction. But we are only focused on those CMEs which is earth directed. They can only impact us, not other CMEs can impact. So so L1 point is just before earth. It's like 0.1 AU from earth. So it's very good point to observe sun or CME continuously, and and to know whether it is earth directed or not. So that's why it's important, and it's also a stable orbit. Any follow up with that?
my next question is, you
Mhm.
mentioned that it will take 1 or 2 days to detect for us that CMS is directly coming towards Earth. So why we have very few days for detection?
Okay, so right now what we are doing, so just imagine from the backside of image, what we are doing is like we are here, right? Let's make it slideshow. We are somewhere here. You can see my cursor, right?
I think the screen is not being
Ma'am,
shared.
Oh,
basically your slide have been removed. Please reshare again.
okay. My bad, my bad, my bad. I thought it's already shared. Okay. Is it visible now?
Yeah.
Okay,
Yeah.
so we are. Oh, so before I said when there is L1 point, you haven't seen it, right? So we are somewhere here at L1 point. Okay, between the Sun Earth line, it's just 0.1 AU ahead of Earth. And as we move away on this orbit, L1 point will we will be with the L1 point. So 24/7 it can observe Sun. Um, you asked like why we are ahead of those, why we have lacking of 1 to 2 days of forecasting, because from L1 point we can have two kinds of observation: remote observation, where we can image Sun from here itself in visible light or EUV images. We can observe Sun from here, and if the CME come to this point, we can see like how's the behavior of CME, what are the magnetic field strength, plasma, whatever, speed, etc. At here, right, at L1 points, just before 0.1 AU. So we can only determine the behavior or the certain characteristics of CME just before 0.1 AU. With images, we are very limited to look for. So if you have an image of someone, if you have my image, you can't tell my behavior, right? So with the image of Sun, we cannot tell that what are the CME speed at that point, right? We can, of course, there are some techniques, but the number is not certain. The number is not robust. So for that, we need observation from the in situ, from the real time. And it's not that we are not working on it. There are missions which go beyond L1 point, Solar Orbiter and PSP, which is very close to Sun. And it's just been few years, couple of years. So we are trying right now. And with the given, as I said, like new missions, modeling techniques, and AI, very soon we will be able to predict it very well before. So let's see.
Thank you so much, ma'am.
Yeah.
So Ayush, we'll move on to the next question. Roberta, are you there now?
Yeah, can you hear me?
Yes.
Yeah, yeah. You can open your camera as well, so it's more
Yeah, sorry,
interactive with that.
yeah, it's already at night, so can I just speak?
Yeah, please go ahead.
Okay.
Yeah, sorry. So this is Roberta from Ethiopia Space Science Society, and I wanted to ask, what key skills would you recommend building for someone who plans to pursue a PhD in astronomy? And also, what helps strengthen a graduate student application for international students, for example, when applying to a US universities?
Okay. So of course, astronomy is again huge. I would be happy to know the particular interest so that I can recommend better institution. As you again, I'm not going to be biased in this recommendation. As you mentioned, the U.S. universities and labs at this time, at this year, USA is not in good condition to just move. It's very hard to get visa, and most of NASA is shut down right now. So yeah, lots of issues. But there are few institutions. As I mentioned, in this where that one NASA Citizen Science Program. If you are very new, I would recommend you to go for conferences. And if you are recommending someone to just involve with the people in this field, I would recommend the first thing is, if there are positions out, just simply apply for those positions and go for the generic interview process. If not, then strongly recommend that go for national international conferences and seminars. That will make your not communication network strong, and because of with that you will get to know if there are opportunities, inside opportunities in their institutions or not. I can suggest you a few um, few platform where you can simply get to know the opportunities in this field, in astronomy especially. Yeah. Okay. So I can career. Okay. I just copy pasting it to the chat box. It's called American Astronomical Society, AAS. It posts a lot of astronomy, space science, solar physics positions out for PhD, postdocs, everything like from masters to faculty positions. So you can go and check that.
Thank you so much, Dr. Soni.
Thank you, Rupina. We'll move on to the next question. Yashwant, are you there?
Yes. Am I audible?
Yes.
Hello, ma'am. My question is about like space weather and aurora. Basically,
Okay.
I'm aware of CMEs and like other CMEs and bursts which causes auroras. And like I'm also aware that these are basically formed when charged particles interact with compound of nitrogen and oxygen in our atmosphere. Like
Yeah.
I have a doubt, how does the characteristics of various birds and CMEs changes the color of aurora? Like basically I'm working on types of colors formed by aurora.
Okay. So again, you're in good and correct way. So CME cannot change the colors directly, of course. CMEs are flares. They can only impact the strength of magnetic field on Earth. Okay, magnetic field or ionosphere. So let's go back just one more time. I will share my screen again. Any of those? This one would be better. So let's see this. So if there is eruption and it interacted with the Earth magnetic field, and magnetic field can just, so the charged particle, they trapped in the magnetic field loops here. And if I have another picture. Okay. Okay, so let's say they trapped in the magnetic field loops and they come to the north pole of Earth, north or south pole of Earth. So the trapped energetic particles or plasma, when they interact with the solar atmosphere, so solar atmosphere has like nitrogen, oxygen, and many other gases. So they can, it's a simple physics if you learned in your BSc or 11th, 12th. So each molecule of any, let's say nitrogen, each molecule has their own electrons in their orbits, and these energetic particles or radiation, they energize that particular electron, and it is in the higher energy level, and when it goes back to the lower or the sustainable energy level, they emits the photons, and there's photons in the same, in different colors. So nitrogen has, I'm not sure, I have to check, but for example, if oxygen, I guess nitrogen has green, I'm not sure, but nitrogen is green, oxygen is red, or hydrogen is blue, something, I'm not sure, just cross check it. But yeah, so different gases, when these energetic particles, they interacted with Earth atmosphere gases, they they energize them in higher energy. The electrons, they excited them. When those excited electrons come back to the lower energy level, they emits. And the emissions are in the colors. Different gases, different colors. CMEs can only, or major eruptions from sun can only impact the location of aurora. So for example, if normal solar wind is there, we can only see auroras in the poles, very high latitude. If there is a huge eruption, like CME last day, 3 days back, eruptions was too huge that they can push Earth magnetic field too close to the sun, and because of that, the trapped energy particles were huge, and we saw auroras in the very low latitude. I'm in Iowa, we are somewhere here in this latitude, and we could see auroras still there. And the event that I mentioned, the Gannon storm, Carrington event in 18 something 1859, that was too huge that we could see auroras from equator itself. So yeah, they can't change the colors. They can only change the location of auroras. They means solar eruption. Yeah, go ahead.
Like it's all about like the characteristics of the CMEs basically impact the charge and how far the aurora global map spreads. Like it
Yes.
depends on how G1 or G2 or G3 the storm affecting the aurora. And basically here the color ranges, or like the different shades of color are being caused by the nitrogen compound and the oxygen compounds, basically not on pure other molecules.
Oh yes, of course, because we have majority of those gases, not the other one, of course. Right.
Okay. Like here, for example, like in most of the areas, we Earth atmosphere is dominated by nitrogen, followed by oxygen.
Yeah.
Thus make the reason for the green shade higher and then red shade in aurora formation.
Yes. Mhm.
And another thing I found is that basically the how far or like how far from the ground level or sea level does the aurora form, like it's basically depending upon, it's about like sometimes it's 200, sometimes it's 700. Basically this is also depending upon the characteristics of like CME, like how impactful is CME.
Yes, of course. That's the response of solar eruptions. Yes.
And like previously we were talking about the higher the charged particles interact with the molecules and like transfer the kinetic energy, and they escape their shell releasing photons in form of light and heat energy.
Yeah.
Yeah, basically this what making the color changing, right? This what you mean to say.
Yeah. Of course, there are lots of mechanism behind it. I'm just talking in a layman language to explain, but of course, there are a lot of physical mechanism behind this.
Actually, the thing is, I'm working on like a review research paper on aurora, so I am
Oh,
aware of all this stuff on all
that's
this stuff
amazing.
of all this stuff of like what does really happens and other things.
Yes,
And
that's
and you mentioned like like I studied in 11th, 12th, and my BSc. Like currently, I'm in my ninth grade.
oh, that's really amazing. Nice. Okay, so right now I'm not a down to earth person. I mean, not in that sense. I mean, I'm not a earth person. So, but in our university, there's a huge group. If you working on auroras, you get to know that Iowa, University of Iowa, there is a huge group of scientists who are working dedicated for aurora studies. So, if you need any help for your study, just connect with me. I'll connect you with the lead scientist of this field. There's one name, Jason. So
I
he's
think I heard about his name somewhere about
Jason
anything.
is one of the best person in our studies. So she is with me in same department. Just connect with me. I'll connect you to her. And there are lots of projects also with her that you can do it from India itself. So if you're fortunate, you will be in good shape of future. So we'll see.
Okay, thank you. And I also worked on some of Aurora citizen science projects, basically like Aurora Service and others.
Uh-huh. That's perfect. Yeah. And you are in good way. Congratulations and good luck.
Thank you, ma'am.
Yeah, wait a second.
Thank you.
Yaswant, I would
Thank
like
you.
to say one more thing. Just share your story, that one, like you have been discovered the dark planet as well. Please tell ma'am that as well.
Like
Is
about
it?
citizen science. It's about citizen science in universe. I participated in various like citizen science program and like discovered a dwarf galaxy, two dwarf galaxies to say, from on universe.
Okay. That's amazing. Congratulations. And which city you are in right now?
I'm in Hyderabad.
Perfect. Okay. Yeah, I mean, impressive.
Thank you, ma'am.
Great.
Thank you, Yashwant. Thank you for such a great interaction. We'll move on to the next one. I think someone raised a hand and now has unraised it. If anybody has any questions, please do raise your hand and we'll take on next questions. Does anybody? Seems like they're not. There are some questions on chat. Somebody, Amoli ma'am is asking, ma'am, can we get kindly suggest some books on solar physics?
Oh,
Amoli ma'am says, if you have any suggestions, please do, ma'am.
oh, there is one book. If somebody is just starting their career in, and I read that book, and I guess most of my batchmates and friends. It's from Bhatnagar. Solar Physics by Bhatnagar. Please read that book. It starts with the ancient solar and then with the modern solar physics. That is one of the best books that I have read so far. And after that, there are a list. Amoli ma'am asked, right? I would give you a list of those books in an email if you want. But yeah, I would strongly recommend to just read the Solar Physics with Bhatnagar by Bhatnagar. That's the one of the best.
Okay, thanks. Huda had asked, I know we have almost regular solar cycles, but what percentage of the sun's behavior is erratic and what percentage is regular?
Oh, okay. So as I guess you are well aware with the solar cycles, so it's 11-year cycle. I can stop sharing right now. So it's 11-year of cycle where there are 2.5 years is a solar maxima, and right now we are in the solar maxima period. So most of the time sun is quiet and we don't have such eruptions that can impact Earth very or effectively. So 2.5 or 3 years is crucial. In that we have 80% of eruptions, right, from the sun. And yeah, so that's the period where we have to be very careful, otherwise we're good, not that in bad condition.
Hmm.
And
Yes.
right now we are in the solar maximum. Sorry, go ahead.
Yeah. Anybody else has any questions?
Brunal,
Okay, Brunal. Yeah, Brunal, please go ahead. Are you able to open your mic?
Am I audible?
Yes, Brunal.
Yeah.
Ma'am, I am in my BSc first year, and I didn't enrolled in a very great university, local university. So there are not many researchers going on especially in physics. So
Okay.
how should I approach? Because I want to be a scientist and researcher, especially in cosmology. So what should I do? I mean, attend workshop, internships, or how should I connect with them?
Okay, thank you for this question. I would be happy to answer this. And may I know which city you are in right now?
I'm in Chandrapur, and it is Gondwana
Oh,
University, not so well known.
which state? Which state?
Maharashtra.
Okay. Okay. So sorry, I'm asking like most of them, like which city and which part of India they are, because India is diverse and different culture is in their cities and states. So it would be better to answer based on that. So Mrunal, just before answer your particular question, let me just share my thing. So I'm from small town like Satna. Satna is in Madhya Pradesh. It's a UP-MP border, not a big city. And I studied in a government school and then government college, not in university. So there was no background who were involved in research, um, and there was no astrophysics or space science guidance when I was started my career.
Yes,
I was in my hometown till my MSc. I did entire my MSc in physics in same hometown. But in this era where we have everything in our hand, right? Everything. You can connect with
ma'am.
anybody in the earth with your phone and they will respond. So what I did for myself is like I was totally dependent on internet. I for example Yashwant, right? If I'm pronouncing his name correctly, Yashwant, yes. So I'm not sure that what how much assistance he is getting from his seniors or professors or their teachers. So right now we don't have this excuse that we don't have good mentors in our community, in our city, or in school or college. You are in internet era, just connect with good mentors online, talk to them, study by your own. When you're going to talk with someone, you have to have a basic homework. So do your homework in your field, in the any of your interest. Connect with the good people in that field. There is a LinkedIn, there is other social media platforms there where you can just simply connect. And believe me, trust me, we means, of course, I can count myself now on that list, but believe me, we are very happy to help, or we are very happy to assist any of you who want to be in this field. So feel free. If you need any further assistance from my end, I'll be happy. And if not, if I won't be able to, I would connect you with the correct person. So, and there is open internet. I don't feel that it can, no one can stop you for being in a small city, small institution, or anywhere. I did my PhD in somewhere in a state university. So don't worry.
Okay, ma'am. Um, I will follow you on LinkedIn as well.
Of course, yeah. You have my email address. It was in the last slide of my presentation. You can simply
Yes, ma'am.
email me personally. I will be happy to answer
Thank you, ma'am.
anytime.
Thank you, Mrinal. Also,
And not
don't
just,
worry, we'll mail you all the details for now. Right. Yeah.
yeah,
Go
okay.
ahead, ma'am. You were saying something?
Just 1 minute. Sorry.
Yeah.
Not only Manal, if anybody in the audience, if they need any assistance, I'd be happy to be there with them. Please go ahead.
Ashutosh, you raise your hand. You can go ahead if you want. I have your question, but please. Ashutosh, are you there?
Yes, sir. Yes, sir. So
Yeah.
I
Go
have a
ahead.
question that I am a MSc Applied Geology student at NIT Rourkela, and I decided to pursue a PhD in planetary geology field. I mean, in that
Okay.
field. So
Mhm.
how I can get into that field?
Okay. So I personally can't suggest you any institution because this is not my expertise. But if you, so there are two way of getting into this research field. Any of those research field. First is if there are, as you are in IIT Rourkela, it's a good institution. You will get a lot of mentorship, but just go for it. The open opportunities, which is already advertised in many platforms in your field, go for that. Otherwise, just connect with the person. Just directly email them that who you are, connect with them, and ask for opportunity if they have. So other unlike Indian research um, culture in abroad, in overseas, what happened, they have their own projects. So like if I'm working on a project and I have opportunities within our team, but we won't advertise it anywhere. Okay, if somebody in your institution or from other institution reach out to us and ask us like we have 3 months of time and we can work with you, if or we have I have this expertise and I could contribute in that way, we simply entertain them, right? So two ways: just connect or just apply for those open advertised opportunities. Otherwise, list all those top or the person who is working in your field, connect them directly, the contact details are in online somewhere, would be, of course, I'm sure. So that these are the two ways to the correct approach to get into this.
Okay, ma'am.
All right. Thank you, Ashutosh. If we are approaching the end of the session, can we also have some more questions? Please, if you have any questions, do raise your hand, or it would be better if you raise your hand. Direct interaction makes it a lot more work. It seems like it's not, but we'll move on to the end of the session. Thanking you, ma'am. Thank you so much for coming in here, for entertaining us for a long time, and having such a great interaction with all the people that came in.
Okay. I have to say you something. I'm just going to send them your email and your LinkedIn profile. So you'll be going to get lots of LinkedIn requests from the Propagation. Okay. Even Yaswant have been sent to you as well. So please accept them, and yeah, you all know.
Sure. Yeah. Okay. Yeah. Just before you end the session, you guys were extremely great audience. Thank you for that. Yeah. Go ahead. Tim.
Okay. Okay, everyone, please turn on the camera so we can just capture this moment as usual. Everyone, please turn on the camera. Okay, with a smile. Yeah. Okay.